Hi Andre, this is Greg Weeks for Sprint 1 for Engine 2. So I tried recording this video once and it was over 12 minutes, so I'm just going to save you a little bit of pain and try to go through this as quickly as possible. Alright, so right off the bat, let's just see what I've got in terms of a demo. Looks kind of terrible right now, but I do have some basic AI going on. Right off the bat, I'm just going to say that my heads-up display is not working correctly. It's still inheriting from Drawable. And I kind of messed it up at the 11th hour. I was trying to mess around with a couple things, and it completely broke on me, and I had too many other things to focus on. So within the next couple days, I'm going to fix my heads-up display system. But what I did implement was a really basic AI in which the enemy tanks are targeting my player and shooting at him. So yeah, that's kind of the biggest thing that I improved in terms of like the user code and this presentation of this demo. Okay. Alright, let's get out of there. So, the first thing on the list is Camera Manager memory leak, and that was just a result of me not actually calling my destructor. So, I am calling the destructor now, and there's a delete for every new. So there was also memory leak in the Scene Manager, and again, that was a result of me just not having anything in my destructor, so I am deleting the current scene and null scene change now. Okay, so we've got updatable memory leak. Again, no destructor being called. Now we're calling the destructor. So, delete for every new. Great. Let's get rid of all of this so we don't get too cluttered. Okay, inputable memory leak. Not that. That's not what I wanted. That's not what I wanted. What? Let's see. Right. Yeah, that doesn't exist. Okay, single key event manager. That's what I wanted to be looking at here. So I was never checking if a single key event manager already existed, and we had some memory leak issues. So I'm just making sure that I'm going through here and deleting everything. Keyword event manager. So I'm now using this if statement to check whether or not we have already registered this key. So if it hasn't been registered, create a new one. If it has, just set it to the iterator second. Okay, cool. And we are cleaning it up. So I don't know if this is like a good implementation, so I'll have to ask you about this. Because I'm actually going through and deleting the second element of this iterator and then erasing the iterator and then clearing the map, and it feels really redundant. But I'm just really bad with using STL and deleting the actual elements of it, so I don't trust these functions, these erase and clears and whatnot. So I need to talk to you about like the actual functionality of these and when it's appropriate to use them, because I just feel safer using delete, but I don't know if it's okay in this situation. Alright, so single key manager never deleted. It's deleted now. Great. Alarmable system. Sorry, I'm trying to go fast here, and I forgot what I did for alarms. So essentially we just had more memory leaks here. Okay. Yeah, it's pretty much exactly the same thing. So we're going through deleting it because I wasn't calling anything in the destructor. A lot of my problems in terms of grading were just not actually deleting things. It's a rookie mistake. But I'm actually using my destructors. So, okay. So I spent most of my time fixing my collision system because I realized that I wasn't actually deleting the collidable group. So if we go here into Collidable Manager, you can see that I've actually created a collision delete command. And what that does is it calls a terminate function on collidable group. So we're just clearing, deleting the pointer instance. This was never called. I was never deleting the instance of collidable group for the specific group that was created before. Um, cool, and that happens at the scene level. So the scene is actually going to call terminate collision groups in the collidable manager. Come on, where'd it go? Alright, and then we're just going to actually use two different STL lists. So we've got a test command and delete command. So the test commands are for the test pair and test self command, and the delete command isn't included in the process collisions. But what it does is when you call terminate collision groups when a scene is destroyed or terminated, deleted, whatever you want to call it, we just go through all of those delete commands and execute them. So we are deleting the collidable group now. Alright. I think that is about it in terms of what I have improved on. Like I said, sprites are kind of on the fritz right now, but within a couple days they should be 100%. Okay, that concludes that. On to the fun bit. So, about half a year ago, I did this project in Unity. I followed a tutorial online on basically how to remake Astroneer in Unity. And the way that this guy was doing that was using a marching cubes algorithm and sort of Unity's built-in tools to make geometry to do this. So this is a procedurally generated planet. So all this geometry was generated at runtime, and it's using these little cubes. I don't know how well you can see this on YouTube, but each of these blue cubes here is sort of a representation of 16 by 16 by 16 unit cubes in Unity. And my knowledge of the algorithm that's used, the marching cubes algorithm, is kind of limited, but I have this handy-dandy little web page that tells you pretty much everything you need to know about marching cubes. And the way that they explain it is you essentially take the vertices of the cubes here and just mess with them based on a certain kind of noise function. So yeah, so you can actually mess with the chunk size here. We can set it down to something like 1, so you can just get a 1 by 1 by 1 representation of what this is supposed to be like. And in Unity, this is extraordinarily inefficient as well. Let's see. Oh, that didn't work at all. Never mind. I'm going to stop messing with this because it's going to take way too much time. But this is essentially what I want to do in C++ into my engine. So I want to create a sphere or some kind of geometrical shape that is procedurally generated with the marching cubes algorithm as I've done here. I don't want to say that I've done it because I basically just followed a tutorial word for word on how to do this and tried to retain as much information on it as I can. And all of this is in C# here. So pretty much the only thing that's going on is we have chunk.cs that's determining the sort of size of the chunk and what you need to do, and then the marching cubes, which is the brunt of it, and this is just the algorithm that's being used to generate the actual geometry. So the challenges for this would be sort of messing with OpenGL and Azul. All of my graphics knowledge obviously is in DirectX, so I don't know how challenging this is going to be in terms of like actually generating the geometry the way that Unity is generating it here in this marching cubes.cs file. So I'm going to have to sort of deep dive into this and see exactly what Unity is handling and if it's feasible for me to get this into our engine without like making like these really extreme systems. But it is essentially just an algorithm, and you're pretty much just messing with vertices. So I think this is doable. A fallback, if I find that Unity is sort of doing way too much work, is essentially doing what I believe Spencer Albin was doing either last year or whenever you had him in class. But he was using the diamond squared algorithm to create procedurally generated terrain, and he wasn't doing like the actual 3D marching cubes implementation of this that I'm doing here in Unity. So yeah, that's it. Essentially, I want to do this, but I'm going to have to speak to you and see if this is actually feasible. But I'm pretty excited about actually getting this done, because if I can understand this, I can make really, really cool games like I tried to make here. Alright, that is about it. I will see you in class.